Hi students, I am so sorry this is late getting out, but I did not have a prep this morning. We had a parent meeting that ended up taking the entire prep period that I had, and I've had students all the rest of the day. So other than lunch, which I ended up with only 15 minutes. So with that being said, here we go. In class today, I gave notes over lesson 3, which is weather forecasts. So some of the things, it starts, don't forget to do your bell ringer, by the way. Don't forget to do the bell ringer. I pushed that out. I did get that out during the beginning of first period, first core. So period 3, core 1. I did get that pushed out. So as you do this, you might look at lesson 3 starting at page 211. Because I'm going to walk you through lesson 3 and the most important information that you need out of lesson 3 instead of assigning the homework. If you already read it and took notes, just listen to this and make sure that you understand the notes that I gave and that you have this information in your notes. You don't have to take another set of notes if you already have this down, okay? All right, so the very first note that I gave them, and pause and go back and forth as you need. The very first note that I gave them was a reminder that meteorologists measure weather variables before making a forecast. So meteorologists study weather, right, and weather patterns. So they measure these variables that we talked about, things like air temperature, air pressure, wind speed and direction, cloud formation, dew point, humidity, relative humidity, precipitation, all those variables. They get those measurements and then they make forecasts about what they think those measurements mean and what will happen in the weather for you. All right. They use surface reports. So a surface report describes a set of weather measurements made on Earth's surface, hence surface report. It's reporting those variables and what those measurements are at Earth's surface. That information is very important as to what's happening as we move like from the west coast to the east coast, because the global winds will carry things that direction. So it's important to know what's happening. Like for us, a lot of times whatever is happening in Lafayette ends up coming our direction, right? So it's important to know those Earth's surface reports and how they affect the forecast for places east or places north. All right, so that surface report. And then they also look at upper air reports, the upper air. So above the surface report into the atmosphere, we're going to have another reading of weather variables. And the way they get that, do you remember in the Bill Nye video about weather that I showed you, that group of students released a weather balloon and there was some equipment attached to the weather balloon? It was a great big, they filled it with helium and it took them quite a while to fill it up, and then they took it out and released it. That's a weather balloon, and it carries some equipment that's going to give them readings or measurements of those weather variables. Like what's the temperature in the upper air? What's the humidity? What's the pressure? So those are things that they're going to get readings from when they release that weather balloon. That's called, when they do that, when they release the weather balloon and all the equipment, they refer to it as the radiosonde. RADIOSONDE. It's on the bottom of page 211 under upper air reports, because that's how they get those upper air reports, is through the radiosonde and sometimes through satellites. Okay, which is our next, page 212. If you look at the figure 14 on page 212, there are two images of the same area, It's United States, continental United States. And there's a visible light satellite image, and then there's an infrared satellite image, okay? So the visible light one doesn't have as much detail to it. It just gives us a picture of what is visible to see what's going on. So it looks like most of the United States is very clear. There's just a little bit of the clouds along the East Coast, if you look at that image on page 212, all right? And then if you look right next to it, there's an infrared satellite picture, and it's got different colors on it, and those different colors are telling you there's some different temperatures going on. And the reason for those different temperatures are the cloud heights. The clouds that form higher up in the atmosphere are going to be colder, and they're not going to rain on you. So that's going to indicate drier weather. When you have warmer clouds that are lower and closer to the surface, those are more possible to rain. So there's information coming from the infrared satellite image. So satellites provide weather information by measuring the radiation given off by Earth's surface and by taking pictures. And then infrared satellite images provide information about cloud temperature and cloud height. How high up is the cloud? If it's really high up, it's not going to cause precipitation, right? Okay. And then Doppler radar, maybe you guys are familiar with Doppler radar. Maybe you've looked at, WTHR has a really cool Doppler radar, and they share their images all the time. It's a really fancy one. And Doppler radar is used to detect precipitation and wind speed. They can tell you exactly how fast that's coming at you using the Doppler effect. All right, so Doppler radar is used to detect precipitation and wind speeds. So like when you see green coming at you on the Doppler radar, that just means we're going to get some rain. Nothing, no storms or anything. Yellow, there's a little bit of stormy weather mixed in, maybe some winds and some higher precipitation rates. And then when you see the red, you're probably going to have some severe storms like thunderstorms. And when it hooks around, that means it could actually turn into a rotation when it has like a J. Then you're going to start probably hearing tornado watches. And then when it actually starts to move into the rotation formation, when after the J comes together, then you're probably going to hear some tornado warnings. And Doppler radar gives us all that information, and it can tell us how fast it's coming at us. So that's a really, really good tool that meteorologists often use now. Okay. Isobars. Isobars are lines that connect places that have equal air pressure. So we use a barometer to measure air pressure. So isobars comes from the word barometer, and they are about air pressure. So if you look at the bottom of page 213, you'll see a line that says 1004. So it's a measurement of pressure, barometric pressure. And then inside that circle, the line that's connected, there's another line that's connected kind of in an oval shape, and it says 1,000. So those two have, those areas have different barometric pressure. One has 1,004, the other has 1,000. All right. The other thing that tells you is the lines give you information about wind speed. It's going to cause wind speed if they're closer together. If there's differences in air pressure, boom, 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 close together, that's going to create wind speeds. That's going to create some differences, creates that wind to push through when there's differences in air pressure like that and close together. All right. Isotherms are lines that connect places that have the same temperature. What do we use to measure temperature? A thermometer. Isotherm. We use a thermometer to measure temperature. So isotherms are lines that connect places that have the same temperature. So there might be a big area that has all the same temperature. There would be a line, and then 25 degrees Fahrenheit. It's a chilly day in a large section. All right. So then we looked at how to read the weather map. There's a key on it. We looked at the bottom of page 213. We noticed at point A, out west, point A, there's the symbol for a stationary front. And then as that stationary front loops down south, it turns into a cold front. We see the blue triangles, and the wind is going south because you can see that those triangles are pointing south. Then it loops on back up and it catches up to a warm front, warm air mass. And you can see that they're both going the same direction. They're both going east. They actually come together, and you can see the occluded front where those two have come together, the cold front and the warm front. It's in the middle of that green avocado shape. And that green means that there's precipitation going on, which would make sense because we're in a low pressure zone. Do you see that capital L that's in red right above the occluded? The reason it's in red is because it's about warm air rising. Low pressure is created by warm air rising. If warm air is rising, it is creating clouds. It can create clouds. And if it's creating clouds, it could rain. Could lead to precipitation. If it's cold enough, it could be snow, right? It'll be precipitation though. Then you see close to the border at where United States and Canada border, you see a blue capital H. That's high pressure. The reason it's blue is because the reason it's high pressure is cold air sinks. Blue means cold. Cold air sinks. Capital H in blue means high pressure. Why is it high pressure? Because cold, dense air is sinking towards the earth. Cold, dense air sinking, high pressure. Clear skies on high pressure. Clouds can't form if air is actually sinking. Clouds can't form up here. They're not getting the evaporation to lead to condensation because it's cold air pushing things down. It's sinking, all right? They put all this information into computer models in order to get long-term forecasts. So you might say, well, what's it going to do next Saturday? Well, they're not going to be exactly sure, but they can make some predictions based on the information they're gathering all around us and putting into this computer model. So this computer model is a computer program that solves a set of complex mathematical formulas. These formulas are used to predict temperature, winds, precipitation, and the types of clouds. If you know the types of clouds, you might know what type of precipitation, if at all, if precipitation will happen at all. All right, so that's lesson 3 in a nutshell. They then spent whatever time was left in class going into their Learn Smart assignment. So the way that you get there is you go into Clever, McGraw-Hill, tap the book. When the book opens, go to the drop-down menu in the upper left corner. Those lines go into that drop-down menu. Click on that, select Homework. Then it should say Chapter 6 Weather Learn Smart. Tap that. It'll look like a blue book with the letters SB on it, Smart Book. Tap that. When you go into that, you want to do the questions. You don't want to do the reading unless you haven't done any reading and you want to go that way into the reading. Because what you can do is when you go into the reading, down in the lower part, it'll say go to questions or something like that. You can then go into the questions, but it's just easier to go straight to answer questions, start questions, or continue questions, depending on if you've been in it at all. That's due Friday before you take the test. So for each class, as you come in to take the test, I'll run your report, and at that time, whatever percentage you have done is what your grade will be. There are a lot of kids that have it done already. And most of the kids that have it done, it took somewhere between 50 and 55 minutes to get through all of the questions, total. 50, 55 minutes, total time. So you started it on Friday, maybe you worked on it during SLT or ST today, and then you had most people had around 15 minutes in class today. So, and then tomorrow we'll play Kahoot, and then we'll have some more class time. It's depends on how well you know the material and how well you've been paying attention and doing the material as leading up to it. All right, no homework. Get these notes down. If you took your own notes, you don't have to take notes over what I gave you. Just make sure that you did the notes over the material I talked to you about. All right.